I asked you to think about what the word optimization means. What does it mean?
Being the best that it can be.
Being the best that it can be, right. Optimization is making something the best that it can be. And so that's what these problems are about. They're all problems that can be modeled with a quadratic. And what we're trying to do is make the situation the best that it can be. So the problem that we have here, and a lot of these relate to similar things, to business. This one is talking about a sporting goods store, and it says it sells reusable water bottles for $8. So, you know, like a water bottle like this for $8. At this price, their weekly sales are approximately 100 items. So that means they sell 100 of these a week. Research says that for every $2 increase in price, the manager can expect to sell 5 fewer water bottles per week. So right now they cost $8 and they sell 100 per week. If we change the price to $10, how many are they going to sell in a week? 95. 5 fewer, right? And then if you increase the price to 12, 90. So as the price goes up, they sell fewer water bottles. But it's not necessarily a bad thing to sell fewer water bottles because you're charging a higher price for them. So you're making more money off of each one. So the optimization part is going to be to figure out what price should they charge to make the most money. The first part, A, says represent this situation with a quadratic function. Now there's one piece of information that I kind of just need to give to you, and that is what revenue is. Do you know that word revenue? It's the money that you take in, right? Revenue is the amount of money that you make. And that's equal to the price of the item multiplied by how many you sell, right? Now, revenue and profit are a little bit different. Revenue is just strictly how much money you bring in. Profit is the money you bring in minus the money that goes out. But we're just concerned here with revenue. We want to maximize the revenue, the amount of money that's coming into the store. It says represent this situation with a quadratic function. If we're going to write an equation, we need some variables. One of them is going to be revenue. So R sounds good. And what do you want for the other one? X? Did you say?
No, P.
P? What's it going to represent?
Actually, X for the number that's sold. So.
It's not going to be the number that's sold that they're varying. So we're not going to use... They're varying the price, but how are they varying it? Right, by price increases, right, which are each 2. So X or N or whatever you decide it's going to be is actually going to be the number of increases in price. Because price is what's varying. So the number of price increases. And then we need to write an equation or a function for R as it relates to X. Revenue as a function of the number of price increases. And we already know that revenue is price multiplied by the number sold. So what's the price? $8. It starts out as $8. But then what happens to the price as you change it increases, right? It increases by $2 each time. So it's going to be plus 2x. That represents the price. $8 that it is now, plus $2 for every price increase. And then it's the number multiplied by the number sold. Well, how many have they sold? 100. And what happens to the number as you increase the price? It goes down. by
Five.
5 for each price increase. And then it says rewrite it should say rewrite the function in vertex form. To put it in vertex form, we actually first have to put it into standard form. So to put that into standard form, we need to expand and simplify. So what I'm going to do is multiply 8 times 100 and 8 times negative 5x. And then 2x times 100 and 2x times negative 5x. So that's expanding because it was in a factored form, which we're not used to working with. It's now almost in standard form. We just need to do the simplifying part. So combining like terms and putting things in the right order. I'm going to put the negative 10x squared first.
Why is it on negative 10x?
That was came from 2x times negative 5x. And then the x's, how many x's do we have altogether?
160.
160. Two different x terms, but the coefficients combine to 160. And then the constant term is 800. So that's just expanding and simplifying. Now it's in standard form. It asks us to put it in vertex form, but that's what we know how to do, right? Take from standard to vertex. So we had to get it to standard first so that we can go to vertex form. So now I'll start that process of completing the square. Negative 10. So it's going to be x squared minus 16x. And then plus 800. Complete the square. So half of 16 is 8. Squared is 64. I'm going through this fairly quickly because you've had a couple of days to kind of do that. But factoring out the negative 10 from the first two terms and then completing the square, you guys need to watch and make sure I don't make any mistakes. Then we've got r of x equals negative 10 x squared minus 16x plus 64. We'll take that negative 64 out, but we have to multiply it by the negative 10 in the front. So that becomes plus 640 plus 800. So I have negative 10 x minus 8 squared plus 1440. There it is in vertex form. So here's the function in vertex form. What does the vertex represent in this situation? Just before we do that, the vertex is 8 and 1440. But Alvin's going to tell us what that represents in this situation because he already told me and it was good. What is it?
So,
I'll type it while you say it.
so it represents like how many times you have to increase the price by 2 to get the maximum amount of revenue.
Hey.
I paraphrased, is that okay? So basically what he says is that it represents the number of price increases that will maximize the revenue. So the number of times that you need to increase the price by $2 to get the revenue the most. And how many times do you need to increase the price?
8 times.
8 times.
That'll be 16, which is like $32 per water bottle.
Crazy, right?
I don't think that's
So
quite accurate.
it actually comes out to, what price should the manager set for the water bottles? Well, right now they are $10. Is that what it was? $8? Plus $2 increases, and we want to do 8 of them, which is equal to $24. So not quite the number you used, but still a big number, right?
I would not like to.
So some people are thinking that seems awfully expensive for a water bottle. $24, maybe you wouldn't spend that, but I think actually a lot of people would spend $24 on a water bottle.
More money spent, there it is.
maybe it's better quality. But really, there's a few things that are involved, right? This is the kind of thing that businesses do, is they look at data and figure out how many people are going to buy things at certain prices, and then they'll do something like this where they try to maximize their revenue. Of course, that's what you want to do as a business, right? Make the most money you can. But there's so many factors involved. This is a simplified kind of situation, and it may not seem reasonable. You know, like if they were selling the water bottle for $8 and then the next week all of a sudden it's $24, people might be like, what? I just bought that last week for $8. And other people might not want to buy it. But a lot of the research will be done prior to putting something on the shelf. But that's that question done.